Hi, and welcome to the Consulting Specifying Engineer webcast, How to Apply Transfer Switch Time Duration WCR, sponsored by Cummins. I'm your moderator, Gary Cohen, and I'm happy to join you today on behalf of Consulting Specifying Engineer and CFE Media and Technology. Before we get started today, here are some tips and tricks to help you get the most from today's webcast. If you are experiencing issues with your slides or audio, just refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of this webcast by adjusting the volume on your own computer or by adjusting the volume on the webcast platform. If you're having technical problems with audio or the slide presentation, just click on the question mark at the top right corner of your screen to access a list of system checks to try. If you do happen to need a technician, type a message in the Ask a Question box and the tech team will get to you as quickly as possible. Individual user experience questions will be answered in the Answered Questions box. Now, if you have questions for the speaker, type those also in the Ask a Question box on the left-hand side of your screen. The live Q&A session will start in about 45 minutes. Today's webcast is being recorded. You will receive an email within a week with the link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of your screen. Those documents will also be available with the on-demand version of this webcast. Now we're going to hear from the sponsor of today's webcast, Cummins. At the conclusion of the video, you may experience a few seconds of silence to compensate for varied internet speeds. Please stay tuned after the video for today's presentation. All right, let's get to it. I am happy to introduce today's presenter, Hassan Obaid. Hassan is a global technical advisor for systems and controls, critical protection at Cummins Power Generation, focusing on technical vision, business strategy, and solving a wide range of complex problems. Hassan has been with Cummins since 2007 in a variety of roles: power systems design engineering, project engineering, and application engineering. He's designed power systems involving switchgear, controls, paralleling, transfer switches, generator sets, and digital solutions. He's developed and conducted numerous technical power seminars to consultant engineers across the globe. Controls. Hassan led the switchgear design for the bare 800 kilowatt mobile power unit for the Air Force. He received his bachelor's degree in computer science and master's degree in electrical engineering from Minnesota State University, Mankato. Thanks for joining us today, Hassan, and I'll throw it over to you. Let's get started.
Thank you, Gary. I appreciate the introduction. Good morning, good afternoon to all of you. I'm so excited to talk to you about this topic today, the WCR topic for transfer switches. First, I'll start with your local Cummins sales and support application engineers. If you have any questions, the Cummins sales application engineers cover both the US and Canada, so this is a handy map for you. Feel free to reach out to them with any questions you may have. So we're going to have to start with a disclaimer. The views and opinions expressed in this course shall not be considered the official position of any regulatory organization and shall not be considered to be nor be relied upon as a formal interpretation. Participants are encouraged to refer to the entire text of all reference documents. In addition, when in doubt, always reach out to your local AHJ. So now that we have that out of the way, we can turn into our course, which is how to apply transfer switch time duration, WCR. Transfer switches are critical components in a power system. and therefore they tested to meet the highest standard in the industry, which is UL 1008. So for this course, we will discuss the UL 1008. So it's a very large standard, but we'll focus on the short circuit testing and cover a little bit of the passing criteria. And then we will demonstrate how this high short circuit and short time withstanding closing rating, how will it help simplify the selection of the overcurrent protection devices, specifically circuit breakers, and then how it'll enable also selective coordination strategies, respectively. Since we're talking about transfer switches, and why not talk about also switchboards and switchgear, touch a little bit about the difference between UL 891 and 1558. So after completing this course, you will be able to discuss the UL 1008 short circuit testing requirements and derive the withstanding closing rating. Learn about the differences between the short circuit withstanding closing ratings and short time rating. And I'll give you a quick hint. The short time rating, it's also a short circuit test. You'll be able to explain how the time-based short circuit withstanding closing ratings simplify the selection of breakers, and examine how the short time withstand and closing ratings enable selective coordination strategies. And like I said, we'll finish with the compare both 1558 and 891 and how do we apply transfer switches depending on the distribution board. So the typical power system components, those what I call is the pieces of the puzzle. This is what I can take and build any system with. You have the sources, a utility, for example, your grid, and you have the backup or the prime power generator sets. We have source switching equipment, so that's commonly known as a transfer switch, and the transfer switch job is to transfer the load from one source to another, whether it's a utility to a generator, two utilities, or generator to generator. Your system also may have distribution boards and control, or a system level control. Distribution board, and the two names that the most commonly named that you're familiar with is a switchgear, which falls under UL 1558. And then there's a switchboard, and the standard for that is UL 891. And in some applications, depending on the complexity of the project, depending on the requirements of the application, you may have a system level controller to orchestrate the entire system. And also your system may have remote monitoring capability, which give you diagnostics, compliance reports, push notifications. That way we can send the right technicians with the right equipment, the right tools to the job to solve the problem quickly and effectively. And obviously what's missing from this are the loads. I think loads are also an essential part of the power system. Your system may also have to worry about grounding, you may have to worry about protection. There's a lot of other pieces that we need to worry about. But from a high level, I can take all these pieces, some of these pieces, and then I can put a simpler system together, such as a generator and a transfer switch, or we can build very complex, elaborate systems with numerous parallel generator sets, many distribution boards, and then we're having to coordinate all the pieces together with a complex system, system level control, and also think about all the failure modes for that system. Or we can go anywhere in between, so between the simpler system and a complex system. Since we only have 1 hour today, we don't have a lot of time, what we're gonna do is we're gonna focus on one aspect, and that is the transfer switch or the source switching equipment known as transfer switches. And we're gonna keep narrowing down the focus to hit that WCR and specifically that short time and time duration rating. So transfer switches are critical in a power system. They are transferring power from that utility or from that backup generator to life, safety, and critical loads. Therefore, they must be designed, built, and tested to a very high standard to ensure reliability. And we use transfer switches in a wide variety of applications, from critical infrastructure, you use them in airports or healthcare, to water, wastewater, to data centers. So when you're designing your system, there are some key considerations or elements that you need to think about when you choose your transfer switch. So some of these elements going in, not in any particular order, you may want to think about the transfer switch type, whether it's automatic or non-automatic. You want to think about the transition type. Is it open or closed? And for closed transition, there's things that we have to worry about, such as we can only be paralleled for 100 millisecond or so, and then it might be delayed. And a delayed transition is the two sources. It's an open transition, and there's this time delay between the transition between the two sources, so that way we give the load enough time to decay in case it's a stored energy load, such as an MRI machine or a motor, to decay to a safe level before we transfer. You also think about the application. Maybe the application is the first item on the list, whether it's a utility to gen, which is the most common application, gen to gen, or utility to utility. There's also the grounding scheme, whether it is a separately derived or a non-separately derived. For separately derived, that means the conductor, the neutral conductor, and the three phases get switched or isolated from the utility and the generator. And for that, we can use a 4-pole transfer switch. For a non-separately derived system, we'll use a 3-pole transfer switch. There's the cable size and entry, whether it's top entry, bottom entry, both sides, and then depending on whether this is be inside an electrical room or an outside. So there is stainless steel enclosure, type 3R, type 1, NEMA 12. And obviously there is the voltage, what voltage we're using, 600 volts for 80 other voltage, and the voltages, and obviously for us here in North America would be 60 hertz. And then the current rating, that this is the standard, the nominal current, 400, 800, 2000, 3000 amps, right? And then there is the fault current capability. And so for that, the number that the acronym that we use is the WCR. We'll derive that WCR. So the typical numbers you might hear is 65,000 amps, 35,000 amps, 100,000 amps. And then there is a selective coordination, and selective coordination also, we'll see that we would need to think about the withstanding closing rating, so it would have to be tied into the short circuit capability. And then obviously there's codes and standards, whether we're meeting NFPA, OCPD, NEMA or ISO, or some radiation electromagnetic compatibility standards. Again, I said that earlier, we're going to narrow down the focus. So from this entire list, this can take us 2 or 3 sessions to cover, but however, we're going to cover the fault current capability, the WCR, and the selective coordination. So this is a typical transfer switch label, and the language in the label is dictated by UL, by the way. So we will try to understand what all these numbers are. So on the top, you'll see that it states clearly that it's a short circuit, withstand closing ratings, and this incidentally, this label also has a short time rating as well. So you'll see in one end, and we list the short circuit capability at a specific voltage, at a specific time duration, and then there's a short time, and then there's a fuse rating. All right, so let's see how we can make sense out of all these numbers and how do we apply them. But in order to derive that and understand that, let's talk about UL 1008 and how we get to the WCR and what does the WCR really mean and stands for. So transfer switches, since they're deployed in mission critical and life safety applications, reliability is paramount. Therefore, transfer switches are subjected to the most stringent test requirements in the industry. And that is UL 1008, which is a standard for safety transfer switch equipment. That's the actual name for the standard. So the standard really outlines a lot of tests for us. They outline, some of the tests they outline is the temperature rise test. So at different locations in the transfer switch, also along the lugs, along the bars, there's a certain number of 75 degrees C or 70 degrees C that we cannot exceed. That's all outlined in the standard. It lists also, it dictates to the manufacturer of the transfer switch to do a dielectric voltage withstand test at different locations in the transfer switch. There is also an overload test that is done on the transfer switch. And there is a contact opening test where they put the transfer switch and they open and close the contacts numerous times. The same thing with the endurance test. And the overload test, by the way, I forgot to mention, is it dictates to the manufacturer at a certain power factor to carry that test. And also they do a short circuit test, and which is what we need to focus on today. And after the short circuit test, they also they ask the manufacturer to perform, or dictate to the manufacturer to perform, a dielectric voltage withstand test to make sure that the transfer switch has not faced any degradation. And then there is an optional test, which is the short time current test. So for us today, like I said, the focus will be on the short circuit test and the optional short time test. So transfer switches have what's called this WCR, withstand and closing rating. What does that mean? How did we get to this acronym? So let's distinguish between clearing a fault and withstanding a fault. So overcurrent protection devices, such as fuses or circuit breakers, are designed or are used to clear a fault. And by clearing a fault, I mean by that is opening up the circuit breaker, opening up the conductor. So opening up the continuity of current or electricity. So therefore, OCPDs, the overcurrent protection devices, they have what's called an ampere interrupting capacity rating, or AIC. If you look at a circuit breaker, you'll see a little label that says, here's the AIC rating for this breaker. The AIC is basically the maximum available fault current that an OCPD will safely clear or open the circuit when a fault is applied at the load side of that OCPD, or on the load side of that breaker or that fuse. And it will do so without creating a hazardous situation. Transfer switches, on the other hand, are not rated, are not designed per UL 1008 to clear a fault, to open up the circuit breakers, to open up the circuit. Unlike circuit breakers, they are rated to withstand the fault. So their contacts should not open. As a matter of fact, their contacts should, if there's a fault, those contacts should not even move by 1 micron or so. So transfer switches, since they are not designed to break the circuit, they must be protected on the load side, on the line side, by an upstream of the transfer switch by an overcurrent protection device. So transfer switches have what's called the WCR, withstand and closing rating. Let's derive that WCR. So per UL 1008 again, transfer switches, so here I have this transfer switch, is energized by source 1, so red is energized, let's use that. So the red is energized, green is de-energized, the circuit breaker is closed, we're down here, the lights are on, we're all happy. So if there is a fault downstream of that transfer switch, and now we have an insane amount of current going through that transfer switch, this transfer switch must withstand that entire fault current for that duration that is dictated on the label. Now, so here we have a fault. The fault is being fed by the source 1, and just let's say for the sake of the argument, whatever caused that fault hasn't vaporized yet. So what happens in this case, this is an OCPD, it will trip, it will open up the circuit, and if it opens up the circuit, the transfer switch senses that, oh, well, I don't see source 1 is available, and let's just say source 2 is a utility, and that utility is available, or maybe a generator, and that generator is available. What it will do is it will go ahead and transfer to that source. So now close onto the fault, because I said whatever caused that fault hasn't vaporized yet, so it will close onto that fault. So therefore, if we have, so now we close onto the fault, now transfer switches get their rating in what's called withstanding and closing rating. So they withstand the fault and then close onto the fault. And this is all outlined by UL 1008. So how does the test is done? So the withstand test starts with the contacts closed, and then a specified fault current. Let's say we want to test this transfer switch for 65,000 amps. So we go to a specific lab in the country, and then we connect the transfer switch, and then we apply, let's say, 65,000 amps, 35,000 amps of fault current is applied for either, and here's where we need to pay attention, is for a specific duration, and that duration is outlined by UL 1008, and then that device that is supplying that current stops. So let's say we want to test it for 0.05 seconds, which translates into 3 cycles at 60 hertz. It stops. Or we can use a specific OCPD. So we get a specific breaker from a specific manufacturer, XYZ, and we test with that breaker. So we can use either or. And then this is the withstand test. The closing test starts with the contacts of the transfer switch open, and then close, and then close onto that fault. Now, the same transfer switch must close onto that fault current under the same condition used in the withstand test. And the same set of contacts, and this is, in reality, this doesn't happen, right? So the same set of contacts per UL are used for both tests, for the withstand test and the closing test. So really, UL subject the transfer switch to extreme, they beat the transfer switch up pretty badly. And so what that means to you is that you're deploying a really reliable equipment in your power system. Okay, so for the short circuit test requirements, like I said, UL 1008 outlines to us how you test the transfer switch and what kind of fault current you test to. So from table 25 of UL 1008, this is from the 8th edition, depending on the transfer switch rating, they dictate to us, okay, what is the short circuit that you test to at a specific power factor, and they list a duration. So duration is the time. Now, note that, this is as a minimum. So if a manufacturer wants to test a 40 amp transfer switch at 30,000 amps, I don't know why they would do that, but they could do that. But as a minimum, they require the manufacturer to list to whatever I'm highlighting here in this table. So a specific power factor for a minimum specific duration. And as a reference in here for you, again, the 0.05 seconds, the most common name that you use in the industry, 3 cycles, right? However, I want to remind you that in the UL 1008, there's no mentions of cycles. It's mostly time. They just mention seconds. And the available fault currents that UL 1008 requires the manufacturer to test to, they list those numbers. So you can choose any one of those numbers. 5,000, 35,000, 42,000, 200,000 amps. And so a manufacturer can't just go and say, all right, well, I want to publish on my label that the transfer switch can meet, let's just go 37,500 volts. No, amps. It has to be one of those numbers listed in here. Now, typically, you have to test for higher than that. So if we certify it to 35,000 amps, the manufacturer tested that to higher than that to account for that power factors, for the different power factors. And also regarding the times, there are 8 different acceptable times, from 0.08 seconds all the way to 0.1 second, and 0.1 second is 6 cycles at 60 hertz. So we cannot, manufacturers cannot just say, all right, I'm going to test this transfer switch to 0.55 seconds. The manufacturer must select one of those numbers, otherwise it won't be acceptable by the standard. So now that we have the transfer switch, the passing criteria for the transfer switch is the ability, having survived this short circuit withstand and closing rating, is that the ability to operate the switch and close onto the opposite source. Door must stay closed. The mechanism shall not fly out. The cables must stay connected to the lugs without insulation damage. No continuity between the normal source and the alternate source, and pass a dielectric test. So basically ensures safety. And it's expected that after you experience a short circuit with this WCR test, is that it is expected that you would replace the transfer switch. And most importantly, that no one gets injured or no damage or fire or burn happen if we experience a short circuit. And also we need to have the ability to transfer to the alternate source if we need to. Okay, so now let's apply some of these concepts. But it looks like I have a quiz. Let's see if we're paying attention. So quiz time. I always get surprised by a quiz. So the question is, which of the following statement is true? Transfer switches have an AIC rating. Transfer switches interrupt fault current. Transfer switches have a WCR rating, or is it all of the above? Let's see the survey, and the answers are coming. I'm seeing a lot of number C. All right. No A. Okay, I see all of the above. So transfer switches have a WCR rating or AIC rating, or do transfer switches interrupt fault current? Okay, I see no one for fault current, which is good. So I'm seeing that all the answers are, see some answers for A, a little bit, I see D, all of the above. The correct answer is C. So transfer switches have a WCR rating. Transfer switches do not have an AIC rating, even though we see that people use that term where they say, what's the AIC rating? Technically, a transfer switch does not have an AIC rating. That's associated with an OCPD, a breaker or a fuse. Transfer switches do not interrupt fault current. So that leaves us with option C, which transfer switches have the withstand and closing rating. Okay, so let's apply this WCR rating. In here, you may not have to use your imagination, and I couldn't draw a picture for you that uses an SKM and make it fit the picture, fit the one slide, so I had to combine art and engineering. So when you're doing your circuit analysis, the first thing you want to do is determine the available fault current at the switch location from the short circuit analysis. And here's what I'm talking about with the bus bars, right? So imagine you have a distribution board in here and you're connecting this down. You might have one branch, you might have a couple branches, but just we're trying to convey a message in here. So you determine the fault current, right? And then you need to select transfer switch with appropriate short circuit ratings. So we select that. And so we said, okay, in here we have 150,000 amps, 85,000 amps, 65,000 amps. Now, the transfer switch must be rated for the available fault current at the line side terminals and must be protected by an overcurrent protection device. So now that we have that, we need to protect the transfer switch. We need to select the appropriate OCPD, and this is what we're going to apply in here. And we can use, if you remember, we can use per the standard UL 1008, we can use the time duration. And if we use the time duration, we can use pretty much a generic UL 489 breaker, or we can use a specific breaker that has been tested with a transfer switch, right? Simple, that's all you have to do. But as you know, that life doesn't go this way. Life is not like a textbook or a cookbook, and you're going to face some major challenges. So some of the challenges that we face is that the detailed coordination studies have not been completed, right? The utility transformer hasn't been selected, or sometimes it might change, so we don't know what the impedance is. Equipment, transfer switches, conductors, etc., must be braced for the fault current that's available. But how do you do that if you haven't completed the short circuit analysis, right? Another major problem that you might be facing is unknown switchboard and switchgear OEMs and breaker selections. I am very confident that some of you on this call have faced that problem, or you're probably facing it right now. Another problem you might face is that you have limited space in the electrical room, right? You don't have, if it's an existing building, you don't have You have a finite amount of space, not infinite. And so where the problem with that is if the transfer switch short circuit capability with WCR does not have the capability to meet what the short circuit analysis gave us, well, you might have to upsize to a bigger transfer switch. Well, what if the room is not big enough to hold it? So now what do we do in that case? So those are some of the challenges. Another challenge that you also probably have been hearing about is the new breaker models from the OEMs. New breakers are coming, and then also transfer switch manufacturers may need to test those new breakers per UL 1008, the 7th edition. So right now in the 8th edition, the changes in the 7th edition made it so that new breakers probably would have to be tested, most likely would have to be tested. So those are some of the challenges, right? So since we're talking about the breaker selections, the breaker with the issues, let's just touch on that topic a little bit. So what are the UL 1008 changes to breakers? Before UL 1008, 7th edition, a new breaker could be added by basically doing a paper study. All we have to do is compare. So if we have a new breaker, and all we have to do is compare that published new breaker TCC curve with the new breaker that we want to test with, or we want to compare it with, and as long as the tested, the new breaker published data is less than or equal to the max published one that we tested with, then we're good to go. However, UL 1008, after the 7th edition, they said, well, we can't really do that anymore. And now what we have to do is that we have to go with and go if the max published trip time of the new breaker must be compared with the actual tested breaker. So when we test a breaker in that laboratory that I talked to you about, specific OCPD, that breaker, so if this is the actual breaker, you have this band in there. So that this band, basically the reason you have a band, this is because you have variability in the manufacturing processes. It's an electromechanical device, a mechanical device. So the manufacturer of a breaker, whether it's GE, Eaton, or Square D, Schneider Electric, they give you this band and say, well, we can guarantee that it will trip anytime, anywhere from here to here. So now having said that, we don't know exactly where the breaker that we tested with in the lab has tripped. So now when we add a new breaker, we want to make sure that that new breaker is less than, the time for it to clear a fault is less than or equal to the one that we tested with. What does that mean to you? All this language that I just said is that a lot of times we have to go and test the breaker with the transfer switch. And that could be time consuming because the lab is not, it's a national lab, UL lab, and then there's lead time and cost associated with it. So let's see how we can overcome some of these problems. So going back to our example, if you remember, we said, let's select, we did the analysis, 150,000 amps all the way down to 65,000 amps. You might have just one branch in the circuit, right? So the concept applies across. So we determined the available fault current. We selected a transfer switch with the appropriate short circuit rating. So in here, the available fault current is 150,000. Here it's 65,000. We say, okay, well, we need a transfer switch at that voltage, and it's very essential to state also the voltage. And we can say, okay, the minimum short circuit rating is 65,000 amps. Now what we do is we need to select the appropriate overcurrent protection device. We can apply the time-based or the specific breaker. So what I'm going to do is I'm going to apply the time duration in this example. So here's an example from one of Cummins transfer switches with the short circuit withstanding closing rating. Like I said, this verbiage is dictated by UL 1008, what a manufacturer should list on their label for the transfer switch. So the voltage is 480, the available fault current is 150,000 amps. Noticing here that it states short circuit withstanding closing rating. The other thing is that this is tell us that the overcurrent protection device must must include an instantaneous trip response. And specifically this label, it states, shall not include a short time trip response. So applying the time duration in here, the time duration is listed as its maximum. So it's the maximum short circuit, 150,000 amps, at the maximum voltage for the maximum duration. What does that mean? That means this transfer switch can withstand 150,000 amps of up to 600 volts for a maximum duration of 0.05 seconds. For the entire duration, which is at 60 hertz, it's 3 cycles, it's 150,000 amps. Now you might say, well, what is it at 480? It's again the same. It's at 480, you can go down with the voltage. So at 480, it is 150,000 amps, but you cannot go up. So if I give you the number at, it's typically would be more. So if it's at 480, you would expect this number to go up. Unfortunately, it is not a linear equation. It's not Ohm's law. It would have to be tested. So whatever a manufacturer listed to the maximum voltage. If this number is at 480, you can go down, but you cannot go up. So you cannot carry the number up to 600. You would need to know what that number is at 600. So now we covered the 150,000 amp. Let's just also apply it again to see that concept again. So again, we're going to apply the time duration. The voltage is 480, and this is the branch in the circuit that's at 85,000 amps. Again, this label clearly indicates that the short circuit capability, RMS, is 85,000 amps at 600 volts, the maximum for 0.05 seconds. And so now what we can do is we can apply, what we're going to apply is we're going to apply, or we've been applying the time duration. And then going back to our example, we're going to be using this example a lot in this presentation. So since we know the time duration is 0.05 seconds, we can use a generic UL 489 breaker that clears that fault current with, so the breaker must also be able to brace or can handle 150,000 amps, right? We can't just apply any breaker. It has to be able to withstand that, can clear that fault. And it needs to clear that fault within that time duration. Because that transfer switch, again, this transfer switch can, in the middle right here at 85,000 amps, it can handle that entire duration for 0.05 seconds. Okay, what about specific breaker? Could we have applied the specific breaker? Absolutely. The label on the transfer switch manufacturers, they use time durations, they use a specific breaker, and they use a specific fuse. Which one is better? It's really, you have a toolbox and you need to apply the right tool to get the work done here. So typically breakers, they can clear a fault. They'll have higher interrupting capability because that short circuit is related to I squared T. So you might see a higher WCR, right? But some of the transfer switches that we're seeing now in the market, that they can go up to a very high withstanding closing rating, so the time-based rating can be utilized. And since it's a generic UL 489 breaker, this goes back to the challenges that I've listed before. So the high time, so if we have a transfer switch that has a high WCR, high withstanding closing rating for time duration, that should help simplify the breaker selection. So that challenge that I talked to you about, where you unknown switchgear, switchboards, or you might change the electrical contractor might have changed the breakers or the electrical distribution board in the middle of the design of the system. There is another name in the industry, or another rating in the industry, that is called any breaker rating. So you might ask, hey, I've heard about the any breaker rating. What's the any breaker rating? The term any breaker is just another way to state the time duration rating, really. That's it. Actually, it's not a term that you'll even see in UL 1008. So UL 1008 does not recognize the word any breaker rating. Again, UL 1008, everything is listed with time. So And where does that term comes from? Well, UL 489 requires molded case circuit breakers, or MCCBs, that are rated at above 400 amps to clear a fault in no more than 0.05 seconds. Less than 400 amps, no more than a cycle and a half, so 0.025 seconds. And so this is where that term comes from. But again, the any breaker rating is just applying the time duration. So what you have for the transfer switch when you protect it, you can use time duration, or you can use a specific OCPD, overcurrent protection device. The specific OCPD can be a breaker or can be a fuse, and those would have to be listed on the transfer switch manufacturer by the transfer switch manufacturer. So when they do the submittal to you as a consultant engineer or to the end client, they'll have that label packaged part of the submittal, and also gets attached to the transfer switch itself as well. But in this case, we have applied the time duration rating. Okay, now we need to talk about the short time rating, but before I do that, I have another quick quiz for you, and this is, the quiz is, what short circuit rating does UL 1008 require? So in the UL 1008, do they require to have WCR, the short circuit WCR based on time duration only? Is it WCR based on a specific overcurrent protection device? Is it either, or is it both? Which one do they dictate for the manufacturer to do? So let's take a look at the surveys. All right, so the result, the question has been released. I see that, and I am seeing all the answers are going to C. All right, let's see what the right answer is. And it looks like the majority of you got it right. It is C. It is either A or B. Glad to hear that I haven't lost you with this presentation. So we can use the time duration, or we can use a specific overcurrent protection device. So you apply whatever is can help you, whatever helps you make your life easier and get the project going. Okay, so going back to our presentation, to our slide earlier, which is the role of Underwriters Laboratory, and we've covered the short circuit. All of this is mandatory. So every transfer switch will have a short circuit rating, and it's required, and you must use the test, you use all that. So now let's talk about the short time current test, which is optional. So the short time current rating, it is again a time duration short circuit test. It is a WCR test, it is a short circuit test, and it is time duration. The durations, however, are set by the manufacturers. A typical example, or the highest number that you see in the industry, is 0.5 seconds. At 60 hertz, that's 30 cycles. So the UL 1008 tells the manufacturers, all right, you tell me what you want to test this to, and now you must test it, and you must pass the test. Again, the manufacturer must pass the same criteria that I outlined before, the same exact one by one. However, there is one more test, and that is you must pass a temperature rise test. And what that means is that the transfer switch the short time rating demonstrates that the transfer switch can still carry the rated current. That means if you have a short circuit incident, and then you have multiple branches in the circuit, and this ungodly amount of current is going through the transfer switches, through the distribution boards, 85,000 amps, and then we're giving time for the breakers downstream to clear that fault, closer to the fault. That transfer switch that has experienced, with the short time rating and experienced that short circuit, it can still be used in the distribution system, and it doesn't have to be replaced. Of course, you have to be checked and make sure that everything is acceptable. However, that's what the short time rating means. It's more of a performance. You're going above and beyond what is needed, and you're going into a performance rating. So how does the label look like? It's similar, and notice how the label clearly states it's short circuit withstanding closing ratings and short time rating. the short time rating, you must, if you're getting a label, you want to make sure that you see the word short circuit, withstand, and closing rating. If it's withstand and not closing, it is not a true short time rating. So a short time, it has to be withstand and closing rating. Notice in here that we can, on this label, we can apply the short circuit time duration, or for 0.05 seconds, which you can see we can go up to 150,000 amps, or we can do a half a second for 125,000 amps. So what does that mean? That means breakers can have a short time trip response. For example, we can use a UL1066 breaker. And with that, this basically will see how that short time simplifies selective coordination. So talking about how do we relate that into a breaker, typical 1066 LSIG breakers, you have about 6 knobs or more on a circuit breaker that we can dial and change to meet our various application needs. We're just going to focus on the short time pickup, which determines the amount of current that the breaker will carry for a short time of period, allowing the downstream breakers enough time to trip and clear the fault. So now how do we tie this back into the transfer switch and into the selective coordination? Well, selective coordination is required for emergency, legally required, and standby critical operation systems. It is, as you can see from the National Electric Codes 732, 700, 701, and 708, selective coordination, the breaker shall be selectively coordinated. Selective coordination is achieved via fuses or breakers, and the transfer switches must be able to support that selective coordination. So this system is not selectively coordinated on one side, and here it is selectively coordinated. So how do we apply that transfer switch rating that we talked about? So here, again, we're using the same example. So we did the fault current analysis. We came up with 125,000 amps in one circuit. If we have maybe 85, maybe 165,000 amps. And so we have the transfer switch with the different ratings. We've talked about that. We selected the right transfer switch with the right WCR. So now the breakers may have a short time duration in them. And so we select, now the time duration goes up to a half a second in this case. And with that, if we select that transfer switch with a time duration and we apply it in the circuit, we can see that how the high short time WCR simplifies selective coordination strategies. Okay, so tie this back into this distribution board and switchgear quickly. So a switchboard is built and designed to UL891 dead front switchboard. It only has MCCBs and ICCBs. There are no UL1066 breakers. The distribution board is evaluated, the switchboard, I should now say switchboard, not just distribution board, is only evaluated for up to, or a lot of times is no more than 0.05, as a minimum 0.05 seconds. There is no short time rating in a switchboard in a UL891. There is only, again, no 1066 breakers. The instantaneous is required. Short circuit can be up to typical numbers 65, 85, or 150. Basic office or commercial building and retail is where we see that. On the other hand, 1058, standard for metal enclosed low voltage power circuit breaker, that's IEEE C37.20.1, designed, tested to NEMA. In there, you will have LVPCB, low voltage power circuit breakers, no molded case circuit breakers. And in it, you'll have the breakers that can be evaluated, the gear, the switch gear can be evaluated up to 30 cycles, or the technical term is 30 cycles at 60 hertz, and this is or 0.5 seconds, which translates into 30 cycles. The instantaneous can be turned off so that we allow downstream circuit breakers to enough time to trip and isolate a fault and selectively coordinate the system. We see that in bigger projects, healthcare, and hospitals. Which one is better really depends on your application, right? Again, we need to select the right product for the right application with the right cost targets. But the difference, again, most importantly, that in the switchboard, 891 instantaneous must be on, no short time. In the switchgear, we can turn off, we can have a short time response, so to allow downstream breakers to enough time to trip. So let's apply that concept. So in this case, we have a 1558 switchgear energizing transfer switch. The UL1066 breakers have a short time trip response. The transfer switch downstream, everything downstream right to this break between the transfers, between the distribution board or the switchgear in here and the transfer switch, everything must be braced for the fault current and the time duration. And then the short time, this should be very clear that the short time trip response of the breaker must be coordinated with the transfer switch and must be coordinated with that label, that one of the labels on the transfer switch that I've shown you earlier. In the next example, that this transfer switch in here is energized by a UL891 distribution board, so we really don't need to use the short time response. You can use it, but you can get a transfer switch with that value, but really you won't be using it. UL489 circuit breakers are used. The circuit breakers must include an instantaneous trip response. And then the circuit breakers must clear that fault in 0.05 seconds or faster, which is 3 cycles at 60 hertz. And so we coordinate that appropriately. Only got a couple more slides over, and then we'll be turning it over to the questions. This should help you. This is from the master spec in case you're looking for a specific language to use. This is just verbatim from the master spec, the product of the American Institute of Architects. You can use that to help you when you're specifying transfer switches of what language to use, whether you want to use time duration or a specific breaker. And now this takes me to the course summary. I hope you still have you on the line, which is how to apply transfer switch WCR rating. In conclusion, transfer switches have short circuit withstand WCR and short time ratings. Both are withstanding closing ratings. Specifications should require the transfer switch short circuit WCR to be coordinated with the OCPD at the fault current available on the line side of the transfer switch, and that language on the previous slide should help you with that. Specify time-based short circuit withstanding closing ratings to simplify the OCPD selection and coordination. And specify short time withstanding closing ratings to enable selective coordination strategies. And so I hope I was able to demonstrate that to you throughout this presentation. And then for additional resources, there are multiple white papers regarding consideration for reliable closed transition transfer switches, along with how to simplify the electrical distribution design using the WCR. And then you can reference all the spec sheets and performance sheets and spec on the Cummins Power Suite library, and this is open for consultants specifying engineers, contractors, and architects and clients as well. And now I'll turn it over to Gary. Thank you very much, and looking forward to your questions.
Thanks so much, Hassan. Now the fun part. Hassan's going to answer a few questions from the audience. If you have questions for Hassan, just type them into the Ask a Question box on your screen. We'll get to as many as time allows. We only have a little bit of time, but no worries. Anything we don't get to today will be posted online at www.cscmag.com. And remember, today, use the Event Resources tab on the left side of your screen. All right, let's jump into some questions, Hassan, if you're ready. You touched on this in your presentation, but is the WCR data transmitted down to lower voltages and or higher voltages?
Yeah, that's again a very good question. So if a manufacturer lists the WCR rating, the withstanding closing rating, they list it at the maximum. So they list the maximum fault current capability at a maximum voltage at a maximum time. typically the consultants are interested. If it's a 600 or 480, do I carry this down? What is it the value at 480 or at 208? It is the same. So from that label, you can carry that number down and you can still use that duration, because we know that the transfer switch at lower voltage will have less energy actually. But you cannot carry it to a higher voltage. So if the label lists the WCR at 480, you cannot use that number at 600. And you cannot use Ohm's law or any other law to calculate it. It has to be tested, unfortunately. So you cannot just simply call the manufacturer and say, well, give me that number. It has to be tested per UL 1008 and has to be published on the spec sheet.
Got it. So how do I plot the ATS on SKM or ETAP? Is there a trip curve?
Very good question. So circuit breakers, fuses, you'll see that they have that typical trip curve. And I think I showed you one of the slides is that LSIG, the TCC curve. For a transfer switch, you can plot it as a dot. So pretend it's just a dot on that TCC curve. And then what you want to do is you assume basically that, so if the fault current is 55,000 amps, or 65,000 amps, you assume per the label or the manufacturer that it will be able to withstand that entire fault current for that entire duration. So there's really no trip curve for a transfer switch. It doesn't vary as you go up and down. They just list it as you can list it as the maximum, and we can use it as a dot on the SKM or ETAP.
Got it. I hate to say this. I think we only have time for about one more here. So let's finish up with we're having issues with new breaker ratings, and it's a definite problem. How can we mitigate these issues?
I hear that a lot, Gary. That comes up time and again, and specifically recently, and specifically after the changes with UL 1008 7th edition. Hopefully what we can do is with the breakers, how do we add a new breaker? The breaker is not listed. I mean, this is the most common question. The breaker is not listed by the manufacturer. How do we go and add it? Hopefully what we can do is, depending on the available fault current, and we can utilize from UL 1008 the fact that we can use either a specific duration or the time duration or a specific breaker. With the time duration, if we apply the time duration, this is when we can utilize if the transfer switch has a high WCR, we can utilize that time duration aspect, and which will basically let our consultant engineers, electrical contractors not to worry about which breaker to use to protect the transfer switch, which is the biggest issue that we see recently in the industry.
Well, thank you to everyone online here for all the great questions. And thank you again to our speaker, Hassan Obaid, for sharing his time and expertise.
Thank you, Gary.
I'd also like to extend a special thanks to the sponsor, Cummins, for sponsoring today's event. But now that we're just about done, we do want to hear how we did. There's an exit survey that's going to pop up on your screen as soon as this webcast ends. Please take a moment to complete that, because we use that information to improve our webcasts. Finally, on behalf of Consulting Specifying Engineer and CFE Media and Technology, I'd like to thank you for attending. This is the end of the webcast. Thank you, goodbye, and have a great afternoon.